Let's shift our focus now and talk about liquids. Liquids are different from gases in a sense that the molecules are closer together. In a liquid, the molecules are relatively close to each other, and but they're still able to move around. They can move around each other. They can flow around objects. In fact, liquids still flow. Just like gases, the only difference between a liquid and gas, though, is that the molecules are much closer together. And what makes the molecules closer together? It is the intermolecular forces. The intermolecular forces, like hydrogen bonding, dipole-dipole interactions, and dispersion forces, are what holds the molecules close together. The strength of these intermolecular forces play a role in properties of the liquid. So two properties I want to talk about with you today are viscosity and surface tension. Viscosity is the resistance to flow. So what are some high viscous liquids? Those examples that you're familiar with are things like honey, maple syrup, corn syrup is another high viscous liquid. So things that are have low viscosity would be things like gasoline. Rubbing alcohol would be another example. Hand sanitizer would be a high viscous liquid. Viscosity is the resistance to flow. So how do intermolecular forces play a role in the viscosity? Well, the stronger the intermolecular forces, the stronger those molecules are going to stay together, and the less likely they're able to move around each other. So the stronger the intermolecular forces, the more viscous the material is. Now, that's not to say that's true for all substances. Determining the relative strength of intermolecular forces is difficult, and you can really only do it to very similar compounds. So you can't really just strictly go by intermolecular forces and looking at the structure of a molecule and determining what the intermolecular forces are and determining which one is more viscous than the other. But intermolecular forces do play a role in viscosity. And for the most part, the stronger the force, the more viscous the material is going to be. Now, another property that plays in viscosity is temperature. So let's remember what temperature is. Temperature is related to the kinetic energy of the molecules that make up the substance. So the higher the temperature, the more energy those molecules have, which means those molecules are moving much faster. So again, if those molecules are moving really fast, then that means they're able to flow more easily. So the viscosity actually decreases. And you probably do this. For example, a lot of people heat up their maple syrup on a stovetop and to make it warm, and when that happens, they just spoon it out with just a spoon and it just falls right off. If you have honey that's really stuck and solidified in a container, popping it into the microwave for a few seconds and heating it up, that will actually cause the honey to become runny. So increasing the temperature decreases the viscosity. Now, another property of liquids that are involved with intermolecular forces are surface tension. And what is surface tension? Surface tension is kind of the attractiveness that liquid molecules have with each other. And so on the surface of a liquid, before we talk about the surface, let's think about within the liquid itself. Within the liquid itself, there's molecules completely surrounding it. Think three-dimensional. There's molecules on all sides of the molecule, and all of those molecules are attracted to each other. But on the surface, the only molecules that are attracted to the molecules on the surface are the ones underneath it. And so what kind of happens is those molecules end up pulling those molecules down. And so in essence, it causes a curvature that happens on the surface of a liquid. Now, that curvature, it kind of makes kind of like a skin on the surface. And so it prevents things from going down. And so this is the way you're kind of water striders, which are little small water bugs, are able to walk on water because of the surface tension of water. There are forces that will prevent the legs of the water striker to penetrate the surface of the liquid. Another example that you can do with surface tension and witness surface tension is you can kind of take a paper clip or take a pin or something that's very light like that in a glass of water, and you can actually lay the paper clip right on the surface of the water and it will float. Or a needle. A needle is usually the easiest thing to do. Sometimes paper clips are rather difficult to actually float on the water, but I mean, I've seen it done. Now, if you do this for a needle, you have your glass of water, you can put a needle floating on top of the water, and you have to do it very gently. You lay it flat, kind of like just parallel to the surface, and it just kind of floats there. Now, if you do this experiment at home, go ahead and let the needle float, but then put a drop of soap in the water. And when you do that, the needle just instantly sinks. And so what did that soap do? Well, soap has what we call a surfactant in it. And what surfactants do is they eliminate the surface tension of liquids, in particular water. And so that surfactant basically got rid of the surface tension of the water, and so then the needle dropped. Now, what other applications do surfactants have? Well, surfactants are part of soap. They're used a lot of times in laundry detergent. Like we said with temperature, the higher the temperature something is, the more energy that the molecules can have, and so they can get into little crevices and cracks, and so generally the higher the temperature of the water is, the more it can get in, and it will bring those soap and surfactant into those crevices and kind of take out all the dirt. And so those little tiny cracks that are seen in your dishes or whatever you're cleaning, then if you don't have that soap in there, the surface tension will prevent it from going into all those individual cracks. And so surface tension is just another property of water that is determined by intermolecular forces.